Okay, so these are a list of identities that's listed in your notes, but I just want to go ahead and talk about these for a couple minutes. So these are some important identities that you want to get down. Now these right here, these first three, not really used too much. We're not going to be looking at those too much in this class. These primarily you're going to be using more. But for the next examples I'll be doing after this, we are going to actually use the first three. So all this says is that your sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals, and tangent and cotangent are going to be reciprocals. That's exactly the same thing that it says here. You're either starting with sine, cosine, tangent, or you're starting with cosecant, secant, and cotangent. So we got those. Now, your cotangent can be written as 1 over tangent, or you can have 1 over cotangent here for that. However, we have some other alternate formulas for tangent and cotangent, and they're going to be involving sines and cosines. So tangent is the same as the y value over the x value when we talked about unit circles. So that's why it's going to be sine over cosine here for this one. For cotangent, that's the x over y, same as cosine over sine. So we have, these are the two identities for that one. Now this one, sine squared plus cosine squared equals 1. Now let's talk about where that comes from. Recall that if you have a unit circle would be a circle with a radius of 1 that's centered at the origin. And that formula for the unit circle was x squared plus y squared equals 1. We also talked about that the x value is same as a cosine, the y value is the same as a sine. So if we make those substitutions, we would get cosine squared plus sine squared equals 1, or written out this way, the order doesn't matter when you're adding. So sine squared plus cosine squared equals 1 would be another identity that you can get directly from the unit circle. Now, these two down here are new. We haven't talked about these yet so far. So how you get these? Well, you're going to start with the formula that we got from the unit circle, x squared plus y squared equals 1. If I take this formula, divide everything through, let's divide this formula through by sine squared. Okay, I would have sine squared over sine squared, I would get 1. If I take this one, divide that by sine squared, I have cosine over sine. Cosine over sine is this one right here. Cotangent squared, that's this one. If I take this one, divide by sine squared, 1 divided by sine over here is going to be cosecant. So 1 over sine is cosecant here. That's where I get this from on the end. So this formula here got derived from sine squared plus cosine squared equals 1. And if I take the whole thing and divide it by cosine squared instead, sine squared divided by cosine would give you a tangent. Cosine over cosine gives you the 1. 1 divided by cosine over here, that's your secant. So that's where that one comes from. So all these three are really the same formula. They're just solved for different things, and all this comes from unit circle. In fact, everything that you see here on the board, all this can actually be derived directly from the unit circle if we know our basic definitions. Okay, we just talked about those identities we had on the board, so now we're going to do a couple examples based on those. We're given that sine t is 2/3 and cosine is going to be square root of 5 over 3. Based on that given information, we want to answer the rest of the following questions. We're going to fill in these. So we want to use identities. So we want to refer back to identities that are in the notes, or you can go back to, just rewind the video to look at the identities that I talked about previously. Cosecant and secant, we can actually get those directly from sine and cosine. Cosecant would be the reciprocal of sine. We talked about that cosecant is the same thing as 1 over sine. Well, if I take 1 over 2 over 3, all that does is flip the fraction. So the easy way to look at that is each of these are reciprocals, so all we're going to do is just take the reciprocals of both of those we have there. So reciprocal of 2/3 is going to be 3/2. The reciprocal of this one is going to be 3 over the square root of 5, and of course I would want to rationalize that. So if I do 3 radical 5 over 5, and that would be the answers for those. So now I have cosecant and I have secant. Okay, now I want to find tangent and cotangent. Now tangent and cotangent, if I look at the formulas that I had on the board earlier, my tangent t is the same thing as sine t over cosine t. So that's the values right here. I can just put those in directly. So sine is going to be 2/3 and my cosine is going to be square root of 5 over 3. So all I'm going to be doing is putting in the two values here by using the identity. Again, that formula is sine over cosine. I have sine and cosine given to me originally, so I can put those directly in here and I can just find out what my tangent is. So when I flip that over, my tangent t is equal to 2/3 times 3 over root 5. The 3's are going to cancel out here, and I would get 2 over radical 5. However, I would also want to rationalize that, so I get 2 radical 5 over 5, and that would be my answer that I would put here. So 2 radical 5 over 5, that's the answer for tangent t. Now my cotangent is going to be the reciprocal of that one. Now I could take the reciprocal of this one, flip it around, the answer here, but I would have to re-rationalize again. So if I don't want to do that, I can actually just take the reciprocal of this one right here. That is exactly the same as 2 root 5 over 5, so all I have to do is take the reciprocal. I would get square root of 5 over 2. That's a lot easier. Then I don't have to worry about doing another rationalizing step when I flip that one. So this would be my final answer. So because of my identities that I had before, I was able to answer all these based on the original 2 pieces of information that were provided. Okay, we have another one we want to use our identities. This one tells us specifically which identity to use. We're given sine t is equal to 7 over 8. This statement says that you're between 0 and pi over 2. All that says is that you're in the first quadrant. So between 0 and 90 degrees essentially that's saying. So we're only going to be in the first quadrant. Using that information, we're going to use this Pythagorean identity. Sine squared plus cosine squared equals 1, and they just want us to find cosine t. So this is basically just going to be a substitution type problem. The sine t is going to go right inside here in place of sine. So you're going to have, instead of sine squared, I'm going to have 7/8 squared. So that would be what sine squared looks like. Remember, sine squared is the same thing as sine of t, and you're squaring that whole result. So sine of t was 7/8. We're squaring that. Plus cosine squared t equals 1. Alright, now we're going to square the top and bottom. 49 over 64 plus cosine squared t equals 1. We're going to subtract 49 over 64 from both sides. We want to get cosine squared by itself. So I have cosine squared t is going to equal 1 minus 49 over 64. If you subtract that with common denominators, you would do 64 over 64. So really you have 64 minus 49. That's going to give you cosine squared t. I'll write that up here. Cosine squared t is going to equal 15 over 64. So that would be 1 minus 49 over 64. Now that I have this, I want to take the square root of both sides. So square root of this, and then I'm going to do the square root of this one also. Now normally, when we do the square root of both sides, normally you would have a plus or minus sign in front of your answer. However, we're not going to include the minus. The reason why is because of this statement right here. It says that you're between 0 and 90 degrees. In that quadrant, everything is positive. That means that my cosine should also be positive in the first quadrant. So because it is, I'm going to ignore the negative answer. Even though you technically should get plus and minus on that, we're going to ignore the negative because you're in the first quadrant. Your cosine's only going to be positive there. So we're just going to consider the positive version of this. You would get cosine t would equal the square root of 15 over 8. So there's no plus or minus. This would be your final answer. That's positive. That would make sense because again you're in the first quadrant.